Hello, class, and welcome to Module 2. While there are no date restrictions on your modules, focus on completing this before the third week of class if you want to stay on a weekly schedule. For this particular module, we're going to go through the overview and objectives. I want to go through the periodic table and then show you the reading preparation and supplementary material that you have available to you. And then I want to go in detail over the two activities that you'll be working with for this particular module. So the overview matter is composed of atoms and bonds. In this module, you will study and be able to describe how atoms arrange and become molecules through the creation of bonds between them. You will study and learn about different types of bonds, and you will become familiar with chemical formula and how they are used to describe molecules. The objectives, you want to give a chemical definitions of elements, atoms, and molecules. You want to explain the difference between formula of a chemical compound and its structure. Explain the difference between molecule, compound, and ion. Name simple binary compounds. Explain the difference between ionic, nonpolar covalent, and polar covalent bonds. And you want to define Avogadro's number, mole, molecular weight, formula weight, and molar mass. For this particular module, you have a periodic table available for you. And so you will want to download it because you'll not only use it for this module, but you'll use it for other modules. So I have downloaded it here and I want to bring it up in this form so you can see it clearly. And so you have in the middle here, it explains what each block represents. So the top number is going to represent the atomic number. And then in the middle is the symbol. For the symbol, it's either a one letter or two letter symbol. If it's one letter, it's always going to be capitalized. If it's two letters, the first letter is capitalized. The second letter is going to be lowercase. So if we see here for cobalt, CO, we have a capital C for and then a lowercase o. But then for like vanadium, it's just a one letter symbol, so we have a capital V. Keep in mind that capital C's and lowercase c's, as well as capital and lowercase s's and o's, they look the same. So you want to make sure that if you're writing those out, that you see that there is a height difference between your capital and lowercase letters. Then underneath the symbol is the name. So CO is cobalt. And then under that is the atomic mass, 58.933. We're going to find in our readings today for this particular module that the number, the atomic mass, also represents the grams in 1 mole of that substance. Right? So next we will see that in this module, it has 3 units. Each unit gives key terms and definitions as well as reading material. And so Unit 1 deals with the elements, atoms, molecules, the chemical formula, chemical structure, compound, and binary compound. And then you'll have a reading material on that. And so you'll see more detailed information about those particular key terms for that particular unit for Module 2. And then we have Unit 2, Avogadro's number, the mole, and molecular mass. And in Unit two's readings, we will see that Avogadro's number is 6.022 times 10 to the 23rd. That number represents atoms if we're talking about an element and molecules if we're talking about a compound. And that's equal to 1 mole. 1 mole is also equal to the number of grams depending upon the element. And so if we look at hydrogen, if we go back to our periodic table, we see it here is 1.008. 1.0 if we're looking at just one decimal place. And so if we go back, all right, so if we have two of them, as we see with this subscript on the hydrogen, then we multiply it by 2 and we get 2.0 grams. And then unit 3 is going to deal with the ion, the bond, ionic bond, covalent bond, and polar bonds. And we're going to look at that in the lab assessment. And then you'll see that there is reading information about the unit 3 portion as well. You're looking at structures and bonding for the different compounds. One other thing that I want to mention is the coloring of this periodic table. And so down here at the bottom, it tells you what the colors represent. Each of these groups, all right, represent characteristics that are similar, so that's why they're grouped together. And so the first column has two groups in it. It has the alkali metals, which are in pink, and then we have hydrogen, which is not a metal, but it does have some properties of the other elements in group 1A. But as you can see by the color, it is a non-metal, and you see the other non-metals over here on the right-hand side. Next to the alkali metals are the alkaline earth metals. And then this section in the middle in yellow, those are the transition metals. Over here in green, these are your basic metals. And then in this zigzag blue area, these are the semi-metals. They're also known as metalloids, and they are called semi-metals because they have properties of both metals as well as non-metals. And then you have group 7A, those are your halogens, and then group 8A, those are your noble gases. And then down here at the bottom, the top row, those are the lanthanide series. The bottom row is the actinide series. And they would be placed if they were in the larger portion of the periodic table, they would be placed here. But for aesthetic reasons, they are placed here at the bottom. All right. All right. So after that material, you have chemical bonds, all right? Bonding with the tutor, how to stick together in chemistry. So this is like a little fun dialogue to help you understand a little bit more about bonding. All right, so read through that. All right, so now we get to the supplementary material. These are different videos to help you better understand the different things that you will be discussing in Module 2. And so these videos give a different perspective other than just the reading to help explain in a different way. And so the first video is on elements and atoms. The next one is on the concept of the mole. So you'll start looking at the calculations that are involved in looking at the mole and looking at grams and Avogadro's number. And so if you have questions though, as you're going through these videos and as you're going through the material for this module, please let me know. And then the last video is on polar versus non-polar. All right. And so that is all the material to help you better understand and be better prepared for the assessments for this module. And so for this module, you have an activity, you have a quiz, as well as a lab assessment. So the quiz, remember, is only one attempt for the quiz and it is time. So make sure that you understand the material before attempting the quiz because remember, you only have one attempt. I want to go over the ionic compound matchmakers. So this is a simulation. And what you're going to do is you are going to build compounds based on the ions. And so there are 20 compounds that you're going to build. After you build each one, you want to take a screenshot or a picture of your screen, and I'm going to show you exactly what that's going to look like. And then after you've done all 20, you're going to receive a medal. And the medal, you want to take a screenshot or a picture as well, and you want to turn it in. So how do we submit them? We submit them here. So you have spaces for each of your different compounds. And remember, you have 20 of them. And you also have place for the final medal. One thing that I do want to mention is that you want to choose the classic simulation. So let's go through it. So this is, let me return to the main menu so that you can see it. So once you click on it, it's going to look like this. All right. You want to click on Start. The classic version is what you're going to do for this assignment. However, there are two other practice assignments that you can work through. You can click on those after you've done the assignment or before just to give you some extra practice. But the classic version is what you're going to submit. All right. And so in here, it says choose a salt. We're going to choose sodium chloride. And so you're going to have the different ions that are going to pop up. So anytime you are building your molecule or your compound, you want to start with the positively charged ion first. So that's sodium in this case. And then you want to add to that the chlorine. All right. And they form this bond. You should hear like a little ding sound once you form the bond. All right. What you want to look for is that your charges are going to balance. So what does that mean? You have a positive charge on the sodium, you have a negative charge on your chlorine. You want to have the same positive number as negative number in order for it to balance. So we have a plus one, we have a negative one. So they cancel out. It makes this a neutral compound. Very important that you make a neutral compound. And so you have one sodium, you have one chlorine. So you want to choose which formula shows one sodium and one chlorine. So if there's no subscripts written, then you know it's only one. All right. And so this is your correct answer. All right. And you'll hear like a da 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 da. I don't know if it picked up in the video, but that will let you know it's correct. All right. And so you want to take a picture of this. So you're going to click on print screen. For mine, it gives me this so that I can actually highlight what I want. I'm not sure how your computer does this, okay? But you want to, you see how I highlighted the whole blue box and even this information down here? Okay, so you want to highlight all of that. So once I've highlighted it all, it's gonna go, it's gonna be copied onto my computer. And so all I'll need to do is to paste it. Okay. So you'll determine how your computer works with copying and pasting. So you see how big it shows up on the screen? You don't want to submit something so large. So you want to make that a little bit smaller. All right. And so now it's about that size. That's a perfect size. So that is your answer for question number one. Okay. You'll do the same thing for all of your questions. You're going to take your screenshots. You're going to copy and paste them, and then you want to make sure that you submit. All right. But if you have questions, excuse me, let me know. You can always, once you've done that one, you go to your second one all the way till you get to the 20th one. All right. The next assignment is the lab assessment. So let me go to the top of this. All right, in the lab assessment, there are a few parts. The first part we're looking at is the polar, nonpolar, and ionic bonds. And so you have this chart. Looks similar to the periodic table, but this is called an electronegativity chart. What this tells us is a particular element's attraction for electrons. Because some elements in the periodic table want to gain electrons, some want to lose electrons. And when we looked at this example, remember we had that positive charge for sodium? That tells us that sodium lost an electron. Chlorine has that negative charge that tells us that chlorine gained an electron. There's certain elements, like our nonmetals, that want to gain electrons and have a positive charge, have a negative charge. And then there's elements like metals that want to lose electrons and have a positive charge. And so, the larger the electronegativity, the greater the attraction for electrons. And so chlorine, we see that's over here, has a large number compared to sodium, which has a small number. Chlorine wants to gain electrons, so it has a higher electronegativity. Sodium likes to lose electrons, so it has a lower electronegativity, right? And we can look at the difference between our electronegativities to determine if we have a nonpolar covalent bond, a polar covalent bond, or an ionic bond. So we're going to look at our example with the sodium and the chlorine. So our sodium, we have a value of zero point 0.9, and our chlorine, we have a value of 3.0. I am going to stop sharing for a minute and I want to look at the whiteboard. There we go, whiteboard. And so I want to show you how you do the calculation. All right. And so it's just basic math that we're looking at. But when we have our sodium, and it's bonded to the chlorine. We're going to show the bond like that, where that dash represents the bond. Our electronegativity value for sodium is zero point 0.9, and for chlorine, it is 3.0. To find the difference, we're going to take 3.0 minus zero point 0.9. When we're setting up our subtraction, because we want the subtraction to give us a positive number, we always start with what is larger and subtract what is smaller. So 3.0 minus zero point 0.9, we get 2.1. All right. This value is what we're going to look at to determine if it is nonpolar covalent, polar covalent, or ionic. This one happens to be ionic. And I'm going to show you why when I go back to the instructions. All right. And so we are going to, all right. So we're going to close that out. We're going to go back to sharing. All right, so we got 2.1, and remember, greater than 1.8, which ours was, makes it an ionic bond. All right, so you're going to go through that information and then you're going to answer the questions based on that. All right, and then we get down to the second part. And the second part, we're going to use a lab simulation where we're looking at salt and sugar. And so, excuse me, you want to click on that. Right here, you see instructions, and this is for the macro tab. And then these are the instructions for the micro tab. All right. So let's go to the lab. So once you click on it, this is the PhET simulation. You want to click play. You can either download it or you can run it. So we're just going to run it. And we're going to wait for a minute while that loads. All right, so now that it's loaded, This is your simulation. So it's similar to what you saw here in the picture, okay? Similar setup. And so you have your salt, you have your sugar. This shows your concentration, your conductivity meter, and then your water. You can increase the water and you can drain some water, okay? You can also look at evaporation. And so when you are doing your salt, okay, just like a salt shaker you have at home, you want to shake the salt into there, okay? And you see that your concentration values start increasing the more salt you add. All right. You see how that chart goes up? You can also click show the values to see what your value is. It also gives you the volume of your solution. All right. And so you can take the conductivity meter, click on it, and put it into the solution. When you do that, you see the light bulb lights up. That means we're conducting electricity. And then to put it back, you just hover it over the portion that says conductivity and it'll go right back. All right. Then you can also remove salt if you've added too much. You can also reset to reset what you're doing. If you look at the micro tab, it looks similar except for the fact that instead of showing the salt as what it looks like, it shows you the molecular view of the sodium and chlorine. It also shows you how the sodium and chloride ions are breaking apart, okay? And it shows you the amounts, okay, the concentrations of those. You can remove salts. You can also reset. They also have a periodic table chart so that you can see you have your metals that are grayed out and then your non-metals that are in pink. Okay. So that is the lab portion for that simulation. So you want to go through step by step. You want to include all your observations. Be very detailed with your observations. And then the last portion has to do with filling in properties of the different compounds. And so you can look them up in the SDS search, all right? And here's a link to that. The SDS search is a file that lists different compounds and chemicals, and it lists things like their melting point, their boiling point, if they're soluble in water, if they're ionized in water, if they're polar, covalent, or ionic, right? So all that information you can find in an SDS. If you cannot find it in the SDS, you can also do a Google search. So either one of those will give you the information you need to fill in the missing information for those two charts. Right? And the last thing is just to give you a critical thinking type question based on what you did in lab. All right. So as you're going through the lab, make sure that if you have any questions that you reach out to me and let me know. So that is all for Module 2. I look forward to seeing you in Module 3.